I want you to picture something for a second. When someone says Rust app, what do you see? Be honest. You're probably imagining a terminal, a black screen, maybe some logs scrolling by, maybe a panic message if things get exciting. Yep, same here. But then you see this: animated buttons, glow effects, smooth motion, hover interactions. And here's the part that doesn't make sense at first. There's no browser, there's no Electron, there's no JavaScript code hiding underneath. This is just Rust. So naturally the question is, what is going on here? Because Rust is not exactly famous for user interfaces, and that's where the Slint crate comes in. It lets you build user interfaces in a declarative way, which basically means you describe what things should look like instead of telling the computer step by step how to draw them. And the way this app is built is actually really clean. Rust handles the logic, Slint handles the visuals, and they stay out of each other's way. And that right here is the reason this combination works so well. So in this video, we're going to cover what is the Slint crate, declarative UI, and the Rust Slint split, Rust as the conductor of the app, the animation phase driving every motion, ownership and safe references in user interface code, .slint files and where the user interface lives, SVG visuals powering buttons, panels, and effects. Like and subscribe and join me for more videos about coding and useful tech content. Alright, let's actually open up the code. Now the first reaction is, this file is small, like suspiciously small, and that is intentional, because Rust isn't doing the user interface work here. It's not drawing buttons, it's not styling panels, it's not worrying about colors, it's acting more like a conductor. It just keeps everything running on time. Now, if we look over here at let phase equals start elapsed, this line is doing way more than it looks like. What it's doing here is generating a value that loops from 0 to 1 over and over again forever. And then this happens, app.setAnimationPhase. So every frame, Rust is feeding that value into the user interface, which means every animation you see is being driven by this one number. That's it. That's the engine. It's basically a heartbeat. And once you realize that, you start seeing it everywhere in the UI. Now, there's another very Rust detail here, and that's this line up here. Now, if you're new to Rust, this might look unnecessary. It's not. This is Rust protecting you. Instead of holding a strong reference to the app, you create a weak one. So every time the timer runs, it checks, hey, does this still exist? If yes, continue. If not, stop. No crashes, no dangling pointers, no mystery bugs. Rust is basically that one friend who won't let you text your ex. Annoying, but correct. Now, one more thing before we leave this file. You've got this function here, compute window scale. This is making your user interface responsive. It looks at the window size, calculates a scale, and clamps it so things don't get ridiculous. That's why everything still looks good when you resize the app. Alright, now let's switch gears. We're going to open up build.rs, and this file is short but important. What it's doing is compiling your Slint user interface ahead of time. As you can see, Slint build, compile, and then it's going into the user interface. It's going in, it's finding the app.slint file, and it's going to start loading all that stuff that's in there, which we're going to take a look at in a second. So instead of loading a user interface at runtime, you're shipping a pre-compiled interface, which means faster startup, better performance, fewer surprises. Now let's move to the user interface. App.slint. Let's jump up to the top. All right. This is your root layout. This is where everything comes together. And the first thing you're going to notice is this doesn't look like Rust at all. You're defining components, properties, layouts, and everything is reactive. So instead of saying move this, then redraw that, you say this depends on that. And the user interface just updates. Now let me ask you something. Why does this user interface look so clean? It's not just the layout, it's not just the animation, there's something else going on. And the answer is SVG. Now let's open up the SVG, spin image button. Setting components, yep, spin image button. All right. Now watch this component. You've got rotation happening here. Let me pull it up on the screen real quick so we can see what we're looking at while we look at the code. This might take a second to run this crate. I'm using cargo run in the terminal, by the way, to build this app. And this code will be available on GitHub. It's just taking a second to load the app so I can show it I'm talking about. Tell you about this SVG being rotated. And so basically the thing being rotated is an SVG, and which means it scales perfectly, it rotates cleanly, there's no blur, no jagged edges. You're not rotating pixels, you're rotating math. And that's why this looks so smooth. Alright. Oh, here we go. Okay. So this button right here, this is an SVG that's actually spinning the spin button right here. And then also down here, the hell portal. If you click on this background, it's going to change into a hell portal. That's actually an SVG in the background that's being rotated, as well as the spin button. So that's a couple examples of what you can do with SVGs inside of Rust. Alright, let me close that. And then the assets are actually right here as well. Here's our hell portal SVG and our spin button SVG. As you can see, it just looks like a button, but it's able to rotate using Rust. So I'm going to talk about right now. Let me go back to where I was at. Alright. Now, so yeah, it's basically the spin image button. Fairly simple code. It's written using Slint. You'll notice these files have a .slint extension. Even though it's a Rust crate, apparently it needs a .slint to run. So that's it. It's pretty simple there. It's basically rotating the rectangle. It's drawing it. It's creating an animate rotation angle, essentially. All right. Now let's move on to styled button.slint. All right. Now this one's pretty long, as you can see from the sidebar. Pretty long. All right. Now look at the borders and look at the glow on the styled button. Oh, here we go. Styled button. So you see the border and the glow? Alright, that crisp edge, that's SVG doing work. You're using vector shapes and gradients to define the look. I guess I should be showing the code. All right, which means no matter how this scales, it stays sharp. If this were a regular image, it would start falling apart really quick. All right, now let's open panels. Panel demo.slint. Where is that at? Assets. Oh. Panel demo.slint. Oh, panel demo. There we go. This is where things start to feel more like a real app. You've got structure, spacing, layered visuals, and again, SVG is likely involved in how these edges and glows are rendered. As you can see, this is the hell portal right here. It's got some accent colors. And we're spinning an SVG, creating a glow panel as well. Okay, because doing this cleanly with raster graphics is not fun. Although I did create this with a codex. So I mean the ChatGPT coding agent. And it took some time, but I got through it. Alright. So now check this out. Hover demo.slint. Now so this enables us to hover over something. It reacts, it scales, it glows, it feels alive. And the best part, you're not writing event listeners everywhere. You're just describing how it should behave, and Slint handles the rest. Also, quick observation, this is basically the user interface version of confidence. It reacts when you get close. Now let's tie everything together. Remember that phase value from Rust? This is where it shows up again in motion demo.slint. Alright, so phase value. Where's the phase value? Let me find this here. Phase value. Oops. Alright. Your user interface is using that value to drive motion. So Rust controls time, and Slint controls how that time looks. That separation is what makes this whole system feel clean. Now zoom out for a second, because this approach is actually solving a real problem. Most user interface stacks force you into trade-offs. Electron is very heavy. Web apps are not fully native. C++, the user interface is powerful but painful. And this gives you something different. Rust gives you speed, safety, and control. Slint gives you clean structure, reactive user interface, and maintainability. And the SVG gives you high quality visuals that scale perfectly. Now you put all that together and you get something that feels modern without the usual baggage. So here is the real takeaway. Rust is not just for backends. It's not just for command line tools. You can build real applications with it. Applications that look good, feel responsive, and don't rely on a browser to function. Now, if you want to push this further, try adding your own SVG assets, play with the animation timing, hook this user interface up to real data, because once this stops being a demo and starts reacting to something real, that's when it gets interesting. And honestly, that's when it stops being a project and starts becoming a product. So if you're building in Rust, this is a direction worth exploring. Go ahead and like and subscribe, and I'll catch you in the next one. And that's all, folks.